Thanks for tuning into the Biped podcast, where we talk about urban clean energy transition and how to improve related concepts, processes, and technologies that facilitate transformation toward climate neutral cities. A key component of energy transition is digital transformation. Next generation technologies can improve how we plan and execute energy policies to achieve sustainable smart cities. And with tools like digital twins, policymaking can become more data driven and forward looking, informed by evidence of what is currently happening in different policy domains and how the situation may change if new measures are introduced. But creating digital twins can be difficult. Relevant datasets need to be obtained, often from multiple parties and sources, to build accurate models. These models and various system components need to be integrated into a coherent whole to enable cross-domain simulations. Front-end interfaces must be intuitive and cater to different user profiles. Well, all in all, building digital twins that are fit for purpose is challenging, but certainly not impossible. And to discuss the benefits of digital twins, the challenges with their implementation, and how to address them, I'm joined by two experts, Arne Schilling and Max Serra. Arne is the head of research and development at Virtual City Systems in Berlin. He has more than 20 years of experience in the field of geoinformation systems and 3D modeling. Arne has a PhD in geoinformatics from University of Heidelberg. His recent research topics include flood simulations, public safety, decision support systems, building information systems, and urban planning. Max Serra is a data architect at DKSR in Berlin with a background in physics and data science. He has previously worked on research and development projects for the aviation industry and AI for manufacturing. With a focus on extracting value from data, Max is leading the analytics and AI activities of Cibora. It's a comprehensive data hub for cities developed by DKSR. Arne and Max, hello. Nice to have you here. How are you doing?
Hi, Pavel. I'm good, yeah. Thanks for having us.
Hi, Pavel. Hi, Arne. Pleasure. And thanks for the invitation. Nice to join you.
Right. Well, my first question is for you, Arne. Since we're focusing on digital twins, I would like to ask you a question about them, because sometimes we hear the term virtual cities, sometimes we hear the term local digital twins, sometimes it's digital urban twins, and the list goes on. I was just wondering if these are minor semantic differences, or do they actually refer to the same kind of digital twins? In your opinion, what is the kind of lowest common denominator that defines and applies to all digital twins?
Yeah, that's a good question also. There's a lot of terms around with partly overlapping meanings. So originally, as you know, we were trying to capture the city environment as a kind of 3D city model or virtual reality model, which is very complicated by its own. So in order to do that, you either go out and measure everything by hand or make photographs, or you find a way to use some kind of remote sensing, laser scanning, things like that, and automate everything. And this is now state of the art. It's not a big deal anymore. Also, the technology for managing all the data, for storing, analyzing, exchanging, visualizing, etc., has reached a state which I would say is very mature. But at the end of that process, the result is maybe a very realistic model, but it's still a very static one. As to the digital twin, probably the main feature is that things are becoming more dynamic. Digital twins are more aware of the things that are happening outside in the real world. For example, you can measure the current traffic conditions and replicate that information in the computer model, or you can get live information about the current energy demand using smart meters and put that somehow in the computer model as well. And the more live data and information you have in the digital twin model, the better it is suitable as a tool for city planning and for decision making. And to be honest, I first thought that digital twin was more like a marketing term, making 3D modeling sound more interesting because sometimes it's really used like that. But meanwhile, the community, especially the scientific community, is really trying to establish a proper concept or a definition, and having dynamic and real-time data from the physical world is definitely part of it.
Right. So, like your answer, Arne. Now, I go to you, Max. I think intuitively, when we or the wider public thinks of digital twins, especially in the smart city context, we tend to think of 3D models that capture how the city looks. Can, say, a 2D map-based visualization be somehow related to a digital twin? Or if you have a dashboard that only shows charts and no 2D or 3D visuals, can this be considered a digital twin? And what if we don't have anything? No 2D view, no 3D view, no charts whatsoever? Does it mean that a digital twin doesn't exist then? What's your answer?
Well, very good question. Digital twins, it's a very interesting concept or a very interesting term, as Arne pointed out, very used in marketing sometimes. But absolutely. So 3D models are the first thing that comes to mind when we think of digital twins. But when we take a step back and evaluate what are digital twins needed for, what is the purpose of building a digital twin, we soon realize that the need is to actually better understand the physical world through a computer model so that we can simulate interventions, that we can test scenarios. But so it happens that the physical world is 3-dimensional or 4-dimensional counting time, but it then becomes a natural go-to resource to have a 3D model because the world is 3D. So we just show everything on 3D. But as Arne was suggesting or indicating the example of energy, when you want to model the energy demand on a city or on a building, you don't need to see the volume of a building. You don't need to see the height of the building. You likely only need a 2D map that allows you to locate the building, to say where this building is here or there. When you want to watch or to evaluate the energy demand over time, so what we are normally referring to as time series datasets, that is a more complicated sort of visualization on a 3D map. And you normally resort to a chart. As you were suggesting, Pavel, you use dashboards that are more chart-based, line plots, bar plots. And when these charts are showing you not only what the sensors are measuring, but they are showing you the model energy demand, for example, then you are really having a digital twin in the background, and you don't need the map support. So I would say that while maps are really convenient when building a digital twin, not only because we are very used to them, and whenever we hear digital twin, we visualize a 3D model, they are also great for geolocating data. I believe we can talk of digital twins even without a 2D or 3D visualization. However, as you suggested, digital twin without visualizations, well, it's conceivable. It would be somehow matching what we've described as a digital twin, but it wouldn't be very useful twin. The key of digital twins is to share knowledge, to create knowledge out of data, and to communicate it, and to reach the public. So for that, you need some sort of visual support.
All right, Max. I like your answer, and I think maybe there's something we also discuss afterwards, towards the end of our podcast, about whether a digital twin exists when you don't see data coming out from it. Arne, back to you. So far, I think we've covered some theoretical ground, and it would be nice to now move to the realm of practice. And if we stay on this topic of energy transition, I was wondering, how can digital twins support cities in this process? what is it specifically that digital twins can do for cities? Can they support them with measuring X and modeling Y and analyzing Z? Maybe there are some interesting use cases you have worked on in the past that you would like to share.
Yeah, so energy is a topic that is a little bit difficult to address, to be honest, because there are so many stakeholders involved. It would be really great to model the energy subsystem in the digital twin, but for that we need more detailed information about the energy consumption and the production, for example. So on the one side, we have private households and the industry. Maybe they have smart meters that are sending information to the power consumption about the power consumption to the grid provider. But this information is usually not accessible because it's confidential, and we need to respect that. Maybe and hopefully we can get some data, also live data on the electricity consumption and in an aggregated form, which is a bit less problematic. And on the other side, we have we could take a look at the local energy production. For example, in the city we are working with in the biped project, it's the city of Aarhus in Denmark. More than 90% of the households are connected to the district heating system. And there's a chance to recreate the district heating system, especially the distribution system and the power stations, in the geographic information system, which is a layer and a part of the digital twin. And once we have all that information available on the energy production and consumption, especially, and where and at what time and what time of the day and how, then we can feed that information into specialized energy modeling frameworks. I think Ali in the previous podcast talked about some of these existing frameworks that we are going to use in the project. As he said, it's still in an early stage of development, but I think that when this is ready, it will be a great tool for analyzing the energy balance within the district or within the city and for finding ways how to increase the energy efficiency, which is actually what we should be looking at. Maybe all this is a very elaborate and very sophisticated approach, and the expectations are a bit too high, but in the meantime, digital twin solutions, as they are now, can already help stakeholders with decision related to energy transition. For example, it's possible to get the building type and estimate the building age using image recognition and machine learning. This will give you some indication of the construction and insulation properties of the buildings. Another example is calculating the solar potential on rooftops based on the 3D city model, which we have actually done for the entire city of Aarhus. And this is great not only for house owners, but also for stakeholders or municipalities who have control over a larger number of buildings, like, for instance, a university campus. Then you can easily see and easily identify the buildings and roof surfaces with the highest solar potential on which you could then install PV panels. And if you have that overview, you can use your budget a little bit more efficiently, I would say.
Yeah. Well, nice overview of some of the use cases there, Arne. And now I have a question for Max. And I was thinking about energy transition and how cities can develop effective pathways for it, because energy transition is a multi-domain field. Multiple domains need to be integrated, such as buildings, mobility, weather, environment, social characteristics. And this diversity of demands poses an integration challenge. Now, what's the best way to address it in a digital twin, in your opinion, Max?
Oh, well, standards, really. That would be the very short answer. But finding suitable standards for the use case or the task at hand is key. I have a small example I like to refer when talking about standards. And for those based in Europe, you likely are familiar with the USB-C European Union Directive. all electronic devices sold from 2025 should have a USB-C. This is the perfect example of how standards are enabling integration. And well, you might have a variety of use cases. If you find a common denominator and agree to use it, then you can focus on all the other things that are more important, and you remove the weight and the work of the different organizations to agree on which standard to use. And absolutely the same applies to local digital twins in the energy transition. Each domain and research group likely is selecting their own data formats, their own protocols, because they need to fit those to their needs. And that's all fine. But when you're trying to build a solution that scales across domains, so as you said, Pavel, energy transition is cross-sectorial or across domains. You need something that goes beyond these very domain-specific tools. For example, what we have two challenges at hand normally with local digital twins, and the first one being data, and the second one being models. On the front of data, how to apply proper governance and accessibility, and how to store, manage, and share the data effectively is a big challenge. And for this purpose, on our data hub Sivora, you've mentioned it previously, we have a data catalog that follows the DCAT AT standard that ensures metadata is properly is encompassing and properly managed. And this enables sharing data in a fluent way. This standard is, as I said before, has to be used across organizations, and this standard is used by the European Data Portal. Therefore, if we use this standard, we are making our system compatible to a wider ecosystem. And this standard has proven very successful in the integration of Sivora with the virtual city system digital twin, because we didn't need to have great talks on how to get data from A to B. We just said we follow this standard, and we were very, very quickly talking about which data is relevant for the use cases, and not bothered about the integration issues. And the next challenge for integration has been models that build up the digital twin, that support the energy transition evaluation of measures. In the Biped project, we have three main modeling domains: energy, mobility, and cross-sectorial. And at the beginning, we had the big question: how are we going to be able to bring all of these very interesting models and very valuable for the city together? And we went with a standard from the Open Geospatial Consortium, so-called API processes standard. And this standard specifies how different models should behave in a very, very simple way. They are very generic definitions that make the model integration very similar across the different domains. So this enabled interoperability very quickly and ensured robustness, because we knew what to expect. And furthermore, using such standards has projecting into the future great benefit, because once you build systems that enforce or use standards like the OGC API processes standard we use in this project, you become compatible with a larger framework and with many more systems. So therefore, I would say the major challenge for in integration is the major solution for the integration challenge is using standards that are suitable and ensure proper interoperability of the systems.
Yeah, standards are key indeed. But is integration really the only challenge? Arne, what do you think? What are the challenges do cities or you as a developer of digital twin technology encounter?
Yeah, I really want to agree with Max. Standards are really important. Otherwise, you cannot achieve interoperability. You cannot rely on your own proprietary specifications and formats and interfaces, because then you're stuck within your little playground. It's not the system that you create is not expandable. For example, you cannot implement the system that you develop for one city. It's not possible to deploy that for other municipalities. But also from my experience, I would say that sustainability in such big projects is still a big challenge. And by sustainability, I don't mean to reduce the carbon footprint. I mean the quality of the technical outcome of the project in terms of usability. Actually, that goes along the same lines. But sometimes the technical solutions are really great and everything is working within the project. But when it comes to adopting the same solution to other cities and other countries, as I mentioned before, maybe on other continents, we run many times into problems because various reasons. It can happen that the partner is not available anymore, that the partner is quitting and cannot be replaced because he was using his own proprietary formats or specifications. But also in other cases, the data is just not available yet in other municipalities, or it's not available in a quality that is really sufficient for us. So in that case, we need to work on the data preparation all over. We need to start from scratch, basically. And that's why I think that, interoperability and relying on international standards, as for example, OGC standards, is really crucial for projects like this to be successful in the future. And for the 3D modeling activities, this is pretty much the case. There's a group of open standards and open source projects that are usually implemented, but as for example, accessing live sensor data or running complicated simulations, it's still a challenge. And in BiPAD, we are now relying on the new OGC standards for doing those complicated processing work, but still need to define a kind of best practice that everybody can agree on. So in that context, I hope that these MIMs, another term, it's short for minimum interoperability mechanisms. It's currently developed by a global network of communities, and we have that network also in the BiPAD project, that these MIMs will help us create more sustainable solutions in the future, but they're still being developed as of now. And Pavel?
Yeah, so I talked about sustainability, interoperability. Now, what about usability? Because I often hear that digital twin technologies are criticized for catering maybe too much for the experts, for the expert community, urban planners, and maybe not strongly enough on ordinary citizens, non-experts, people who don't have this technical background. So, Max, what do we do? How do we make digital twins more accessible to the wider public?
Big topic, yeah. I mean, you can build the best system, but if no one uses it, it's not really bringing any value. I think you mentioned user experience. I think that is the key. We need to ensure that the user enjoys and likes to use the system. And I'm not referring on a playful way, but really on a user experience perspective. It has to be intuitive and friendly to use. And this sometimes means likely to have to cater different user profiles in different ways. I think there is sometimes a bit the perspective of, or the saying one size fits all, the approach of one solution is suitable for everyone. But that is very narrow-minded. And I think working on user profiles and working on user stories, really doing doing research, really sitting down with the people in the city administration, but also the citizens, understanding what do they expect, what is their intention with the system, what is their background, understanding this user profile. As I said, it's a more technical term, right? But or domain niche term. You need to really make your solution or your digital twin coherent for that person, and that might be for a different person completely unnecessary because they already know what you're talking about. And yeah, I think really working on this user experience is key. Making the front end convey the essential information, the relevant information, declutter it from additional layers, but keep the layers maybe for those users that really need them. Right? There is different depth that you should provide, and normally these digital twins go very deep. You click on a building and you get like a whole list of things when you actually just need to look at element 24 on that list.
And also, I think maybe when at the level of use cases, make digital twins interesting and relevant for citizens. At this level, Arne mentioned solar potential, and that's the module that is integrated into the digital twin of Biped. And we often hear that without citizens, energy transition cannot happen because we need everyone on board, we need the industry, and we need citizens to participate. And one way to facilitate this transition is to help people switch to alternative energy sources, to use renewable energy more often. And they can do it in many different ways. One is, for example, to install solar panels on their roofs and get electricity not from the grid, but generate their own electricity. But how do you know if it's worthwhile? And is it going to work on your roof? How much solar potential does it get? Without digital twins, it might not be easy, but with the solar app that Arne has built, I think it really can facilitate this informed decision making. People go to the map, they find their building, then they can run some modeling simulations and see how much solar irradiation the roof gets. There's even this calculator that shows you if it's worth investing or not, how much money you're going to spend, over what time you're going to see a financial return from your investment. So I think all these benefits are really useful for citizens. And I think with this focus on solar potential, digital twins can be relevant to the wider public, especially in the context of energy transition. That's how I see things.
Yeah, absolutely. The solar planner is very comprehensive tool. It's very friendly to use, and I think it hits spot on this domain depth, but also relevance of information. It really conveys what the user is looking for in a understandable way. This return on investment graph, it's really spot on.
Yeah, I hope it's gonna be useful and easy to use because it's meant to be used by the public, by house owners, by citizens. And you can start right away and look at the colorful map showing you really the solar potential as a color ramp. But you can also tweak the technical parameters if you want. And yeah, that's maybe a topic, how to design these kind of maybe decision support systems that help you making important decisions. Sometimes you're really not the experts and you don't want to mess with the technical parameters because you don't understand everything, but you want to be able to push on the button and see some initial results. And if you want to go deeper, maybe you can open up a more sophisticated user interface that you can interact with, which is then for the experts. So in terms of end users, it's really not defined, and it really depends on what you want to do. In the BytePad project, we have a big set of stakeholders defined. Not every stakeholder is an end user, but for example, if we have politicians that want to have some insights on the energy transitions, they want to have a really easy to use interface and something that's easy to use. As I said, experts might have other requirements, so it really depends.
Yeah, and maybe if we go back to the question that I asked at the beginning, is there a digital twin when we don't see any visuals coming from the data? It's a bit like that the popular question we often hear: does the tree make a sound if there's no one to hear it? Because as also Joanna mentioned, digital twins of cities, they are more and more reliant on IoT real-time data. So I'm thinking, if data is collected and sent from sensors and is stored somewhere on a database, somewhere in the cloud or wherever, do we already have basically a precondition for a digital twin? Does it need to be visualized, or the mere fact that we collected real time on the physical phenomenon and we collected this data, it's being stored somewhere? Is this already basically a digital twin that maybe isn't visualized? We don't see its appearance, but the data is there, like the bones are there. We don't see the flesh yet, but the bones are there.
It needs to be accessible at least, so otherwise it doesn't make any sense. But it does need to be visualized in a sophisticated 3D environment for sure. This is just one view to or on the digital twin, I would say. We have other tools like dashboards, so you can create a report maybe showing you a better layout and easier to understand representation of the data that you want to analyze. So there's multiple ways to access the digital twin. So it's not just the extended 3D model, it's a lot more. It contains a lot of deep information, but this information must be accessible in one way or the other. And the question is, what's the best way to do it? There's can create 2D maps, 3D scenes, you can create reports, you can create dashboards, things like that.
Absolutely. I would just add to that, and the best way to do it is not always the same, it always depends who the end user is, what's the purpose of using the digital twin, right? Sometimes less is more, and just a chart showing you the forecasted energy production on a district is all you need, rather than some flashy visualizations that hide the information. But yeah, it's a very critical question, Pavel. I like it.
Philosophical question.
Yes. I guess
right.
I agree to Arne with the accessibility. It needs to be usable, and at the end, what we're trying to do with digital twins is to improve the physical world, to make energy transition, greener cities, and that has to be used. So whatever means it uses, either a 3D map or just a chart on a dashboard, as long as it reaches the proper public.
Well, on this note, I'd like to thank our guests. I'd like to thank you, Arne and Max, for your really insightful responses. I certainly learned a lot about digital twins and how they can support energy transition. My knowledge has improved, and I hope that our listeners too learned something new and interesting from today's discussion. And we'll be having more exciting conversations like this one in the future. So do stay tuned, and let's see you on the next one.